Alright, in our previous module we explored the pandas series, which is a one-dimensional structure, basically resembling a Python list or an array, essentially a column of data when we look at it visually. And in this module we'll begin our exploration of the pandas data frame, which is really the workhorse of this entire pandas library. It's the most popular object within it. And the data frame is a two-dimensional object, so the closest thing that it can be compared to is a table, kind of like you'd see in Excel or SQL. It's two-dimensional, so that means that there's rows and there's columns. And at this point, I think it's a good idea to clarify exactly what we mean when we say dimensional, because this is a term that really confused me when I started. So dimensional doesn't have anything to do with the number of rows or the number of columns. Rather, it has to do with how many points of information you need in order to arrive at any single data point. So if you think about something like a series, if I wanted to extract any specific value, I would only need one point of reference. I would need, let's say, the row number or the row index. If I'm looking at a list of 500 different Pokemon and somebody says, give me the 450th Pokemon, I would know what that's referring to. In comparison, if you look at something like a table that has rows and columns and somebody says, give me the value from row 450 or give me the value from column 4, simply one detail by itself, one point of reference by itself, does not tell us how to arrive at any point in the table. We need the intersection. We need the specific row and the specific column in order to arrive at any valid data point within that table structure. So the number of points of reference that we need is really the number of dimensions that there are. So a pandas data frame is a two-dimensional object because you need 2 points of reference. You need a row and you need a column in order to get any specific value. And we'll dive into this plenty of times as we proceed throughout this module and all of the upcoming modules as well. Let's begin now by creating a brand new Jupyter Notebook, and in this lesson we'll just import the CSV that we'll be using throughout this module and the upcoming lessons, and then we'll proceed to introduce the data frame in upcoming lessons. So I'm navigated to my Jupyter Navigator, and I'm going to click New on the right here and select my Conda root environment. At this point, let's give our notebook a name. So I'm going to click on Untitled, and I'm going to call this DataFrames 1. This is actually the first of 3 modules focused on the pandas data frame. It is really the largest object and the most important one in pandas, so I wanted to make sure we cover as much as we possibly can and introduce a lot of different data sets. So one module of 20 or so lessons wasn't enough, so I've expanded it to 3 full modules just focused on this one object. So this is going to be the first of 3. Let's say OK here. And of course, we can't work with pandas until we import it. Let's do that with the import keyword, import pandas as PD to assign it an alias. I'm going to hold Shift, press Enter here to execute and import my pandas. At this point, I'm going to press Escape to bring us into command mode and hold my B key a bit just to create some cells at the bottom. This is highly recommended whenever you create a notebook, just so there's no issues with things like scrolling. Usually when you have a few empty cells to work with below your current output, you don't have things like accidental scrolling up and down. So I've created a few cells here, and let's take a look at the data set that we'll be using throughout this module. So I'm going to use my pandas library in PD. I'm going to call our familiar read CSV method, open my parentheses because it is a method, and the CSV in this case is called nba.csv. So in this case, we don't have to use the squeeze parameter or anything else because we want to import the entire CSV file, and we want it to be rendered as a table, which is the default option of the read CSV method. So let's take a look at this data set. So this is actually a collection of every player in the NBA, that's the National Basketball Association, I think for the 2015 to 2016 season. So in every row we have the name of the player, the team they played on, their number, which is their jersey number or their team number. We have their position, which is one of 5 values. We have their age, their height, their weight, the college they attended, and their salary for that year. You'll notice a couple interesting things about this data frame, and we'll take care of some of these problems later. First, you're going to see these NaN values start to pop up. These basically mean blank or null or missing or empty values. Basically, whenever you see NaN, that's the pandas designation to indicate that that cell is missing a value. If I were to open this CSV file in something like Excel, this cell right here would simply be blank. Pandas prefers to not go with the direct blank approach and just specifically write the NaN designation for all empty cells. So you can see one example here, you can see one example here and here, and I just tossed in an additional problem intentionally in this data set just to make things fun. If I scroll down all the way to the bottom here, you'll see that we have a row of nulls or empty values at the very bottom of the data set for every single column. And that's going to throw some kind of issues into the data. I'll talk about that shortly. Before I do that, though, I just want to point out that the structure of this is very similar to a series. We have the first 30 rows presented here, followed by a ellipses, which indicates that that part has been cut out or truncated. And then finally, we conclude with the last 30 rows of our data set. Similarly to a series, the index here is being generated automatically because we didn't specify what column to use as the index in our read CSV method. So this is not coming from the CSV. This is coming directly from pandas. And as we scroll down, we see that there are 458 rows, so the last index position ends at 457 and starts at 0. So a final note, and then one more thing we have to do. You'll notice that things like the age column and the weight column are represented as floating point numbers. If you were to open this CSV in Excel, what you'd see is that these numbers are actually being stored as integers, so there are no decimal points, there are no floating points. The reason that pandas does this is if there are any NaN or null values within a column, especially a numeric column, pandas has to default to floating point in order to be able to store them. I don't know what the technical reasons for this is on the back end, but just keep that in mind. And because you remember we have that last row at the very bottom of the data set consisting of all nulls, as long as we have that one value in each column that's a null, even if the entire column otherwise is an integer, pandas is going to convert it to a floating point. We'll show you how to deal with this problem shortly, but just keep in mind that these numbers are not appearing as they are in our original data set. Pandas is converting them automatically. Finally, the last thing I want to do here is assign this data frame to a variable, otherwise it's basically going to be thrown away in memory. And the variable name that I'm going to use throughout this module is just going to be NBA. 3 letters, short and sweet. And again, simply writing it does not do anything. We have to re-execute the cell to read the CSV again and then make sure that the NBA variable is pointing to it. So when I execute this with Shift-Enter, we're all ready to go with NBA. And in the next lesson, we'll start diving into some of the attributes and methods that are shared between the pandas series and the pandas data frame objects.